Alright, this is a pre-lab for the refraction lab. And for the refraction lab, what you're going to need is a light box, which provides a light source. You're going to need an adapter to plug that in. You're also going to need a block. It's either going to be glass or acrylic, just depending on which one you get. Something to write with, of course, and then you'll need a ruler and a protractor and a piece of paper. You're also going to want to go to physics classroom if you haven't had a chance to do that. And we're going to scroll down on physics classroom because this lab is about refraction. And there's an equation you're going to use today called Snell's law. So we want to go into Snell's law, which is lesson 2. Actually, all of this talks about refraction, but this gets into the mathematics of refraction. If you scroll about halfway down, they give you a nice equation, and they also describe all the variables. And you can see that n1 sine theta 1 equals n2 sine theta 2, where theta 1 is the angle of incidence, theta 2 is the angle of refraction. n1 is the index of refraction of the incident medium. Index of refraction is the index of refraction of the medium in which the light actually bends. It's what causes light to bend or slow down. So here we have the light source plugged in, and you can see that as light goes in at an angle, it's faint because I have the light on, but you can see the beam that comes out the other side here, and it's come out appearing to be bent. In other words, the incident ray, which is right here, comes in, and you would think it would come out over here, but it kind of is offset a little bit, and we call that refraction. And refraction really depends on the angle. So if it comes in at 90 degrees to the glass, it doesn't bend at all. But if it comes in at an angle, you'll see it begins to offset or refract. And that has to do with the fact that the index of refraction of air is different than the index of refraction of this medium, the block. So the index of refraction of air is approximately 1. That's easy to remember. And what we're doing in today's lab is trying to find out the index of refraction of this block. Alright, first thing you want to do is to outline the block, because we're going to pick the block up several times and move it, and we want to make sure that we have a nice diagram that represents where the block was. So you can see here that it's clear where the block was. So I'm going to come in with a light source. Now this would be approximately 90 degrees, so what I want to do is come in at 3 different angles today. So I'm going to come in at a slight angle. This might be, about 20 degrees, 15 or 20 degrees. This might be about 30 or 45. And then we want to come in at a sharp angle, a large angle, maybe 60 or 70. Just 3 different degrees. And we want to make sure that the ray comes out the opposite side, the parallel side in which it went in. In other words, we don't want the ray to pop out over here. We want it to stay on the parallel side. So I'm going to come in. I'm just going to pick this one right here, and I'm going to make sure my block is inside, and I'm going to mark where it comes in, the incident ray comes in, and I'm going to mark where the refracted ray comes out. I drew the point where it entered, but I should also draw a dot over here so I can draw a full line of the incident ray. I'll do the same thing over here for the refracted ray. Okay? Now I can move this and move the block, and what I want to do is I want to draw a line that connects these 2 dots, where it entered and where it exited. Okay. Now we also need a normal line. Okay, a normal line is going to be able to give us some kind of indication as to what the angle is. So we can't just haphazardly draw a normal line. What we have to do is make sure that our normal line is perfectly perpendicular to the surface. And the way to do that is put your protractor up here and draw a line that's 90 degrees to the surface from the point of entry of the incident ray. And I'm going to draw the dotted line, a dotted line for the normal, and I'm going to carry it all the way into the glass, into the back. So now I have a nice normal line there. And I can draw an incident ray to this point of origin where it enters the boundary. And I'm even going to put an arrow here to indicate that's the direction it's going. And I'll draw an arrow there representing that it's coming out. So the angle of incidence ray to the normal line, so this is theta I, and the refracted ray is from the angle of refraction to the normal line, which is this. Okay? So all we want is the ray coming in and then the ray that's actually inside the glass. Now, the ray that came out of the glass we actually don't care about, but we needed to indicate it. I want you to have a full sketch of it so you can see how it bends as it comes into the glass. And we're not going to use that, but if you wanted to, what you could do is draw another normal line where it comes out that were perfectly perpendicular to the surface. Okay, so in this case, if it's coming this way and it's going out, this is now theta I and this is theta R. So what I want you to be aware of is that the refracted angle coming out of the block into the air should be the same as the incident angle going from the air into the block. And the angle refracted in the block is the angle incident in the block to the air. So these two should be equal. So what I'm saying here is there's some symmetry, and you can choose either pair of these to do the lab. It doesn't matter which pair. When you're working this out, you're going to use the equation from physics classroom, and you're going to plug in all your variables, and what we're trying to solve for is the index of refraction of the block. This is what we're looking for. All right, good luck.